So in this lesson, we'll be focusing on the very basic of a geometric sequence. Because before we can do any calculation or applying these geometric sequences, we must be able to familiarize ourselves with the concept first. We'll also be talking about some of the important terms you can see down here. By the end of the video, you should be fairly comfortable with 1. Recognizing a geometric sequence, and 2. Finding the common ratio of 1. Let's get started with the very basic by reviewing what a sequence is. A sequence is a set of objects arranged in a very specific order. A geometric sequence might look something like this: 2, 4, 8, and 16, and so on. This leads to an introduction of a very key concept of a common ratio, and so is the very first step into identifying a geometric sequence. The common ratio of a geometric sequence can be defined as a fixed variable multiplied by the previous term to get the current term, or the current term to get the next term. Returning to this very basic geometric sequence, we can see down here, the common ratio is being multiplied each time is 2 to get the new value within the sequence. Simple enough that an ESS student might be able to do it. However, be careful here. If we flip this geometric sequence, that is 16, 8, 4, and 2, this is still a geometric sequence, as we can find the common ratio, and this common ratio is the multiplicative ratio of 1/2. This means that the fraction of 1/2 is being multiplied every time to the previous term to get the new term.
Now that we have hopefully understood the fundamentals of a geometric sequence, let's all try some examples. We will begin with the easy ones, then it will progressively get harder, then finally something more challenging. Look at the sequence below. 1, 1/4, 1/16, and 1/64. Is this a geometric sequence? Well, to find out, we must find if there is a common ratio. The common ratio could easily be obtainable by this simple formula: current term divided by the previous term. By dividing 1/4 by 1, we will get a result of 1/4. To check our answer, multiply 1/4 by 1/4, which in this case is 1/16. This is an example of a geometric sequence. Moving into a more intermediate example, considering the following sequence: r to the power of 1, r to the power of 2, and r to the power of 3. Let us apply the same steps. R to the power of 2 divided by r is r. R to the power of 2 times r equal r to the power of 3. This is once again a geometric sequence. Now we are ready for the last and most difficult examples, and fair enough, you guys are going to rage like I did. First, carefully look at this set of data. Natural log of x, natural log 19/72x, natural log 1/16x. Is this a geometric sequence or an arithmetic sequence? Find the common ratio or the common difference, pause the video, and give this question a fair shake because you guys are going to need it. Okay, now tackle this problem. I suggest you doing the opposite and find out if the sequence is an arithmetic with a common difference. Natural log of x, subtract natural log 19/72x equal natural log 1/4x. By the rule of logarithm, and natural log 19/72x plus natural log 1/4x equal natural log 1/16x. This sequence is an arithmetic sequence, therefore it is not a geometric sequence. I hope you enjoy this lesson and find it helpful. Peace, because I hate this chapter. I love you, Miss Stacy. Peace out.